Welcome to the last lesson in our radicals unit. We are going to solve radical equations. So a radical equation is an equation with at least one radical whose radicand contains a variable. A solution to a radical equation is a root of the equation. So we say the equation has a real root. When we solve a radical equation, we have to identify any restrictions on the variable. And we also need to identify whether any roots are extraneous by determining whether the value satisfies the original equation. So we just need to check our work at the very end. So let's go ahead and do some examples of solving some radicals. We're going to start simple by just having one radical. And we're going to solve for each equation. So you need to, again, state the restrictions and verify the solution. So right off the bat here, I need to state that x has to be greater or equal to 0 because we can't have a negative on the inside of a radical. So again, x has to be greater or equal to 0 for that to happen. Now I'm going to try to solve. So the method is I'm just going to square both sides in order to get rid of the square root, because I know the square root and the square are going to cancel out. And I'm going to be left with 5x on the left-hand side of the equal sign. And then the right side of the equal sign, I have 10 squared, so that's 10 times 10, which is 100. Then lastly, to isolate my x, I'm going to divide by 5 on each side. And 100 divided by 5 is 20. So that would be our answer to A. Now, I'm not done yet. I'm still going to verify our solution. I'm going to do that on the side here. So I need to make sure this 20 actually works. So I'm going to plug in 20 in for x into the original equation. And I just make sure that both the left-hand side and the right-hand side are equal to each other. So 5 times 20 is 100. And the square root of 100 is 10. So we have 10 equals 10. This is satisfied. Our solution is good. Moving on to our next one. We have the root of 5x is equal to negative 10. So this one's slightly different just because we have a negative in front of the 10. And we're going to see what's going to happen when we have that. So again, for our restriction, x has to be greater or equal to 0 because we need the radicand to be positive or 0, but it can't be negative. Now I'm going to square both sides. Remember to put everything in brackets when you square it. So then we would have 5x on our left-hand side because the square and the square root are going to cancel out. And negative 10 times negative 10 is positive 100. Now I'm going to divide both sides by 5 in order to isolate my x. 100 divided by 5 is 20. So I do get the same answer as A, but let's see if this actually works out or not. So we have 5 times 20 on the inside of radicand and should be equal to negative 10. Let's see. So 5 times 20 is 100 and the square root of 100 is 10. And this is not true. So when we verified it, x equals 20 is actually not a solution. Moving on to C. I'm going to start off by stating what our restriction is. Again, x has to be greater or equal to 0. Now I'm going to go ahead and square both sides. Remember to include in the brackets because then you'll know you're squaring both sides. Do not miss the coefficient of 4 in front of that root x. Okay, so when I do this, on the left-hand side of my equal sign, I have 3 squared. That's 3 times 3, which is 9. And then on my right-hand side, I have 4 root x. This squared does apply to the 4 and it also applies to the root x. So 4 squared is 16. And the root of x squared cancels each other out, so we're just left with x. Now I'm going to divide both sides by 16 to isolate my x. So then my final answer is 9 out of 16. Again, we need to verify this to make sure this is true. Okay, so I'm going to plug 9 over 16 into our original equation. And we need to see if the left-hand side equals the right-hand side. So the square root of 9 is 3. The square root of 16 is 4. You can see the 4 will cancel out top and bottom of the fraction. We're going to get 3 equals 3. And this is satisfied. It's good. Moving on to D. Before I square both sides, I'm going to get rid of this -7 because I can move that to the left-hand side of the equal sign if I added 7 to both sides. So 13 plus 7 is 20. Now this is a lot easier for us to square both sides. Another thing I could also do before I begin is divide both sides by 2 because I can do 20 divided by 2. And that's 10. And then now this question looks pretty similar to A, where I can just go ahead and square both sides like this. 10 squared is 100, and then the square and the square root are going to cancel out, we're left with x plus 1. Moving the plus 1 to the other side, or in other words, subtracting both sides by 1, we're going to get x equals 99 as our answer. Before I go ahead and verify, I still have to state my restriction because I didn't do that in the beginning. So here, be careful because x plus 1 has to be greater or equal to 0. The whole thing underneath our radical has to be greater or equal to 0. So if I move this 1 to the other side, that just means that x has to be greater or equal to -1. And that would be our restriction. So now let's verify our solution. I'm going to put 99 in for x. All right, so 99 plus 1 is 100. The square root of 100 is 10. 2 times 10 is 20, and then minus 7 from 20 is 13. So this is good. Moving on to our next one here. Again, I want to get the square root by itself if I can, so I'm going to move this 5 to the other side by subtracting both sides by 5. 12 minus 5 is 7. Now I'm going to go ahead and square both sides. Square and the square root are going to cancel out, and then 7 squared is 49. Trying to isolate my x here, so I'm going to move the 1 to the other side. I'm going to add 1 on both sides. So 49 plus 1 is 50. Then dividing both sides by 2. 50 divided by 2 is 25, and that would be our answer. Now to state our restriction, 2x minus 1 has to be greater or equal to 0 because we can't have a negative inside of our square root. So I'm going to rearrange this so we can get x by itself. So I'm going to add 1 on both sides and then divide both sides by 2. X has to be greater or equal to a half. Now verifying our solution, be 5 plus the square root of 2 times 25, then minus 1, and let's see if it equals to 12. So 2 times 25 is 50. 50 minus 1 is 49. The square root of 49 is 7. 5 plus 7 is 12, and our equation is satisfied here. Now let's move on to a different type of question. What happens if we have two radicals, one on either side of the equal sign? Well, what we want to do is simplify this as much as we can before we go ahead and square both sides. So for this one, because if we take a look at what we have, I can combine these into one side, and then I can combine those onto one side of the equal sign. So what I'm going to do is minus 2 root x on both sides, and then I'm going to add 4 on both sides. Okay, so then I'm going to be left with root 2 on the one side, and then 1 plus 4 is 5 on the other. So all I did is rearrange our equation. Now I'm going to go ahead and square both sides. So this 2 is going to go into the coefficient 2 and the square root as a reminder. So 2 squared is 4. Square root of x squared is going to be x, and then 5 squared is 25. Lastly, I am going to divide both sides by 4 in order to isolate my x. So our answer is 25 over 4. Part of the question says we have to verify our solution, so I'm going to do that on the side here. I'm going to put 25 over 4 in for our x. Okay, so the square root of 25 is 5, and the square root of 4 is 2. Same thing on the other side of our equal sign. Now we can see that 4 divided by 2 gives us 2, and our 2's on this side are going to cancel out. So we have 2 times 5 in the numerator, which is 10, and then we're left with 5 plus 1 on the right hand side. 10 minus 4 is 6, and 5 plus 1 is 6, so this is satisfied. Moving on to B, this looks like a complex mess. It does right now, but what we can do again is to move things around a little bit. So what I'm going to do here is I'm going to try to at least get these on one side. So I'm going to subtract both sides by 5 then. Now we're going to have 2 plus the root of 3x is equal to the root of 5x plus 4. And that's the best we can do right now. So this is at the point where I'm going to square both sides. On our left-hand side, be careful. This is 2 plus the root of 3x times 2 plus the root of 3x. So if you want, you can rewrite it out like that, just so you don't make a mistake and just do something bad, like just doing these two, because that's completely wrong. We have to multiply 2 plus the root of 3x with itself. Okay, so I'm going to do my rainbows here, looking like this. So 2 times 2 is 4. 2 times the root of 3x is 2 root of 3x. You're going to have that again. And then for our last one, root of 3x times root of 3x is just 3x. So I'm going to collect my like terms. So we have 4 root 3x. I'm going to move everything else to the other side. So 5x minus 3x is 2x. And our 4's cancel out. Now at this stage, we still have that root sign, but it looks simple enough that I could just square both sides again. So this 2 is going to go with the 4 and with the root. So 4 squared is 16. Then we're left with 3x. And this 2 again would go to the 2 and the x, so this becomes 4x squared. Now I'm going to multiply our left-hand side. So 16 minus 3x is 48x. I'm going to continue on over here. I'm going to move everything to one side, because if I divide both sides by a 4x, I am going to miss a solution. So what we need to do here is actually factor. The common factor I have between those two terms is 4x. Then I'll be left with x minus 12. So our value for x then is 0 and 12. Now we're going to go ahead and verify. And there's 2 solutions for us to verify. So let's do x equals 0 first, and then after we can do x equals 12. So for x equals 0, we're going to have 7 plus the root of 0 plus, sorry, not plus, but equals the root of 0 plus 4, which is just 4 plus 5. So that's 7 is equal to 2 plus 5. That's 7 equals 7, so it's good. Now I'm going to try x equals 12. Okay, so 3 times 12 is 36. 5 times 12 is 60, plus 4, 64. The root of 36 is 6. The root of 64 is 8. 7 plus 6 is 13. And then 8 plus 5 is also 13. So this is good as well. Our last type of question we're going to cover are extraneous roots. So we're going to state our restrictions and then solve for them. So our restriction is only going to come from the root sign. Remember, 5 minus n has to be greater or equal to 0. So if I try to solve for n is smaller than 5. Okay, now we're going to go ahead and try to solve for n. So how I'm going to rearrange this here, I'm going to have the root on the other side and then n and our number on the left-hand side. So I'm going to add 7 to both sides, and then I'm going to move this root onto the other side. So we're left with n plus 7 on one side, and the root of 5 minus n. So just did some rearranging there. From this point, I'm going to go ahead and square both sides. So n plus 7 times n plus 7 is n squared plus 14n plus 49. Our right-hand side is 5 minus n. I'm going to collect my like terms. So I'm going to subtract 5 on both sides and add n to both sides. And then I'm going to go ahead and factor. So factors of 44 would be 4 and 11. And we can create a 15 with that, so we just need a positive 4 and a positive 11. So n is equal to then negative 4 and negative 11. Moving on to the next question. We need to state the restriction before we go ahead and try to solve this. So on the left side of our equal sign, x minus 1 has to be greater or equal to 0. Or in other words, x is greater or equal to 1. So that's one restriction. And then if you look at the right-hand side, 2x plus 3 has to be greater or equal to 0. And if I want to isolate my x, I just move the 3 to the other side and then divide both sides by 2. So x is greater or equal to negative 3 over 2. If I were to draw a number line to describe this, let's say negative 3 over 2 is here, let's say 1 is here. If x is greater or equal to 1, this is the graph that we're going to get. And if I try to graph the other one, x is greater or equal to negative 3 over 2, this is what we get. So overall, they have this in common, so that is going to be our restriction then. Our restriction is x is greater or equal to 1. Now, solving for this, I'm going to square both of these to get rid of the square root. So that's x minus 1 is equal to 2x plus 3. I'm going to rearrange, subtract x on both sides, and then subtract 3 on both sides. So x equals negative 4. But the problem is x has to be greater or equal to 1. So it doesn't fit within that domain. This is outside the domain. So no solution. Moving on to the last question, we have a problem-solving question to do. The formula d equals the root of 13x can be used to estimate the distance of the horizon d kilometers from an observer at a height of x meters above sea level. An observer is in a hot air balloon that's attached to the top of a 200-meter tower whose base is at sea level. So we're going to go ahead and draw a diagram as we read this because it is a lot of information. So we have a tower here that is 200 meters tall. We know that a hot air balloon is attached to this tower. It's my little hot air balloon here. And then we also know the distance to the horizon is 100 kilometers. And it did say that d is the distance of the horizon. So we know that d is 100 kilometers. We want to know how high above the tower must this balloon be so that the observer's distance is d equals 100 kilometers. So this would be, let's just call this height. We're looking for the height here. So when we talk about x meters above sea level, this x meters can be described as 200 meters plus that little distance of h. So x is equal to 200 plus h. That's our distance above the sea level. Now let's put this all together. D is equal to the root of 13x. I'm going to put in 100 kilometers in for d, and then for x I'll put in 200 plus h. So instead of simplifying the inside, I'm just going to square both sides first. It really doesn't matter which order you do. So we're going to get 10,000 on our left-hand side, and then 13 times 200 plus h on our right-hand side. Instead of multiplying this 13 with the 200 and the h, I'm going to divide both sides by 13 instead. And now we have 200 plus h on our right-hand side. I'm going to move the 200 to the left-hand side by subtracting both sides by 200. And then now we just need to do a little calculation. You can either use fractions in order to do this. If it's in the calculator section of your test, then you go ahead and use a calculator. But h is going to be 569 meters. And that would be your final answer. This is the height above the 200 meters.